Yeah, good evening all. Let me know audio and video is fine too. Right. Yeah, welcome to everyone. I hope audio and video all fine. I have not seen any reply yet. Thanks for joining today. And in case if you have not liked this session or you did not share to anyone so far, please do for one cast to help others. Okay. Thanks for liking the session as well as sharing the session with your friends too. As we have seen, successfully we are at 22nd lecture. Like the first day I promised like we'll have a lot of good sessions, and still you don't believe you will have the very good practice sessions at the end of this course playlist. So here we are always moving step by step and learning a lot of things and practicing a lot of things during the session. और जो जैसे ही ASC प्रोग्रामिंग की क्लास लेक्चर्स कंप्लीट होता है, लास्ट में गेट PYQs के साथ साथ और कुछ नया स्टैंडर्ड की गेट स्टैंडर्ड की क्वेश्चंस भी विल प्रैक्टिस, है ना. In case if you are not watched the previous lectures, go to the previous lectures and complete it and catch me in the next weekend. We will have the longer sessions for the practice, like 3 to 4 hour session for the practice based on my availability, right? I'll inform you one day ahead, like Friday or Thursday, so that you can plan well for the practice sessions too. Okay, good. In a previous session, we have seen like a lot of examples on structures and unions, as well as storage classes, functions, recursion, correct? Now we'll move on to, sorry, functions we have not, right? I'm very sorry, that was other batch. Okay, we have completed arrays and pointers, then we completed storage classes, correct? Then structures and unions. Now we are moving to the functions. Is it right? Anybody can reply? Yeah, I get. We just completed structures and unions. Before that, we had a practice sessions. Great. So what are we going to do in these functions, right? Before starting the function, right, I'll let you know how to complete the previous topics along with our lectures, and you wanted to practice more. You have very good resources at GFG. But if you're not aware, like I can show you multiple websites are there. There are multiple pages are there in Geeks for Geeks. So go to Geeks for Geeks, right? So just search what you can search, C programming. Right, you will get the direct page to start the C programming language tutorial, and in that you will see all the topics which are well organized, right? The topics which I have covered so far, everything is there up to here, right? So, and functions you have early, but it's okay. So you can go to the functions and you can start from here, right? What is a function? Function definition clearly mentioned here, and how the function looks like. And if in case if you wanted to learn in advance before coming to my session, and you can visit always the Geeks for Geeks website for learning everything from the scratch. Even more than gate preparation you can do here. Interview questions are there if you are preparing for the placement. So you can do a lot. So if you look at this, and it's a well organized, the course is already there. Anybody want to go with the self-learned, self-paced, then you can go with this the modules that we have on the Geeks for Geeks. Okay, so now we are starting C functions, and before that we have completed a lot of topics. Okay, right? Many people ask, sir, do I have the notes for this? Yes, you have the well structured notes on the Geeks for Geeks. You will definitely enjoy, because it was made by our Sandeep sir, and then many other experts involved in that, and very well curated content is available with you. Okay, अब चलते हैं function. आपको क्या पता है function बारे में? What do you know about the function? Right? In a C language, of course, this function, module, procedure, these things are named in different places, different ways. Correct? C is a procedural oriented language. So C is built based on the functions only. If you want to write a program, you should write the functions. You have no other choice. Correct? Okay, I'll just show you one simple example, very simple example. Okay, you have written this program many times, like #include stdio.h, and then maybe you have written something like this, void or int main, and in that you might be used a printf. Okay. Can you tell me here how many functions are there? Okay, storage classes will do anything. Okay, I'm sorry for that too. After function recursion, we'll have that. Thanks for informing. Because there are multiple batches goes sometimes, I thought that it is covered or not. But anyhow, I'm just watching the playlist too. And after the function recursion, we'll have storage classes. I have an habit of doing storage classes after the recursion, so that you will understand more about the storage classes. Good, Nitin. Two. Excellent. In this, you have two functions. One, you have a main function. Other, you have a printf function. Correct? How many of you know the main syntax and printf syntax? Anybody aware? If you go to Google, search, like you have main syntax. That's all you need to do, right, in C language. We are so lucky that Geeks for Geeks comes first always, and we are so thankful to the Geeks for Geeks to see that main function. Right, we're almost there. Going on. Right, this is what the main syntax. If anybody can see it, return type is integer, the main, and there are two arguments. These two are command line arguments. How many arguments that you are passing, and then what are those arguments? So this is a set of strings on the character pointer, right? So array of the strings, basically array of characters. So it is going to have a character pointers, basically array of character pointers. So each pointer points to the string. Like this is how many arguments that you have, the argument count basically. And this is how the main syntax looks like, but we never use all the arguments. And return type also, you can write void or int, it is your choice. Okay, if you write a void, then no need to return. If you write int, you should return some integer value. So this is how the main syntax is designed, right? Is this user defined or built in? Anybody? Is this a main function built-in type or user defined type? I just want to know clearly, what are you thinking about this function? आपको पता होना चाहिए what is main. And no doubt the printf is definitely built in, because you are just calling it. What is main? if main is built in, then you should not write a code inside the main. Remember that. If main is built in, you should never write a code, because you should just call a main like a printf. Printf, you are not writing the code, you are calling it. Are you calling the main? Are you defining the main? You tell me, what is it? It can be absent. Who told you to compulsory? Anyone? There was a mistake that I am doing during my BTech. Main is not compulsory. You can compile a C program without a main, but you can't execute a C program without a main. Both are different. You can write a C program without a main, but you can't execute it. You should link to some other program. Never use that word. Every C program definitely should contain a main. That's the wrong statement, right? You can have 10 C programs, but 9 programs you can link to the one program. The main program you can link, you have to write the main function. Remaining 9 programs, you don't need a main function. Okay? So aware that the main is not compulsory in every C program. Okay? We'll see that examples too. है ना? क्या मैं तेलुगु मीडियम तेलुगु में पढ़ाऊं? अनुराग, have you understood? The main is not a built-in type. ये क्या है? Everything we are writing in English, क्या होता है समझने के लिए? Right? दोनों यूज कर रहा हूं ना. So this is user defined, है ना? So you are, आप यहां पर सब कुछ लिख रहा है, वो ऑलरेडी नहीं था मेन के अंदर. बट ये कंपलसरी फंक्शन अगर इस सी प्रोग्राम को आप एग्जीक्यूट करना चाहते तो ये कंपलसरी लिखना जरूरी है. अगर आपको ये इस प्रोग्राम को किसी और प्रोग्राम के साथ लिंक करना है, इसमें मेन जरूरत नहीं है. ठीक? तो प्लीज डोंट से दैट मेन इज कंपलसरी, मेन इज बिल्ट इन. ऑल आर रॉन्ग स्टेटमेंट्स. मेन इज नॉट कंपलसरी, बट कंपलसरी इन द प्रोग्राम जो आपको एग्जीक्यूट करना था. और सेकंड, मेन बिल्ट इन टाइप नहीं है, यूजर डिफाइंड. आपको जो चाहिए वो लिखना, जिस सीक्वेंस में चाहिए वो लिखना. बट मेन फंक्शन के लिए ये मेन ऐसे ये नाम ऐसे है, वो ऑलरेडी कंपाइलर में कुछ ऐसे डिफाइंड था, 2 आर्गुमेंट्स इसके अंदर. राइट? वो भी ऑप्शनल है, वो भी कंपलसरी नहीं है. देखा, यहां कोई आर्गुमेंट ही पास ही नहीं कर रहा है. ठीक है? ठीक. तो अब समझ में आया होगा, सी लैंग्वेज में देयर आर 2 टाइप्स ऑफ फंक्शंस. ये फंक्शंस की बात इसलिए है, तो व्हाट इज द एडवांटेज ऑफ यूजिंग द फंक्शंस इन सी लैंग्वेज? व्हाट इज द एडवांटेज? वन एडवांटेज इज द मॉड्यूलरिटी. तो आपकी जो प्रोग्राम होता है ना, उसको मॉड्यूल वाइज यू कैन राइट मल्टीपल प्रोग्राम्स, यू कैन राइट मल्टीपल फंक्शंस. ये आपकी चॉइस है. तो मॉड्यूलरिटी बनता है. अगर आपके पास बहुत सारे फंक्शंस है, लेकिन एक ही मेन फंक्शन लिखा हो, उसके सब कुछ अंदर लिखा है, तो बहुत बड़ा बनता है. अगर आपके पास 1000 लाइन्स है, तो उसको 20 फंक्शंस ने बना लो. तो 20 फंक्शंस का मीनिंग भी ऐसे बना लो, तो आपको समझ में आया जल्दी. लाइक आप अर्थमेटिक ऑपरेशन से बिल्ड कर रहा है. एडिशन के लिए एक फंक्शन बना लो, मल्टीप्लिकेशन के लिए एक फंक्शन बना लो, डिवीजन के लिए एक फंक्शन बना लो. राइट? सो कैन कॉल देम व्हेनेवर यू नीड इट. एक मॉड्यूलरिटी है, तो कैन डिवाइड द प्रोग्राम इनटू मल्टीपल फंक्शंस. एक एडवांटेज है. करेक्ट? दूसरा क्या है? व्हाट इज द सेकंड? रीयूजेबिलिटी. मतलब एक छोटा ब्रेक बनाया, कोड छोटा ब्लॉक बनाया, और उसको कभी भी चाहिए, देखो ये मेन बनाया, इसको मुझे दोबारा चाहिए, किसी और फंक्शन में भी मेन को कॉल कर सकता हूं मैं. जैसे प्रिंटफ है, मुझे 100 बार प्रिंटफ कॉल करना है, तो डायरेक्टली कॉल कर सकते हैं. अगर प्रिंटफ डिफाइन करना है, बार बार मुश्किल होता है. करेक्ट? तो रीयूजेबिलिटी. So you can write a smaller part of the or you can write a one function, you can reuse as many times you want it. You can reduce the code because of reusability. And आपकी प्रोग्राम बहुत सिंपल एंड इजी लगता है समझने के लिए. बहुत लेंथी हो सकता है कभी कभी. Do you know anything else other than this? If you make the functions in a programming language, what are the advantages that you see? Modularity, reusability, simple and easy. जो जो फंक्शंस इंपॉर्टेंट होता है, जैसे printf, ये हर सी प्रोग्राम के आपको लिए scanf, printf, इस तरह स्टेटमेंट्स बहुत इंपॉर्टेंट होता है, राइट। अगर यूजर को इस फंक्शन की बिल्ड करना है, बहुत टाइम लगता है, राइट। कीबोर्ड से इंटरेक्ट करना है, स्क्रीन से इंटरेक्ट करना है, और किसी डिवाइस से इंटरेक्ट करना है, उनके लिए प्रोग्राम बनाना उतना ईजी नहीं है, राइट। इतना उसके लिए फंक्शन बनाना, तो बिल्ट इन फंक्शंस के साथ एडवांटेज क्या है? तो एक बार इंप्लीमेंट किया और बाकी दुनिया यूज कर सकते हैं। तो advantages like you can write a lot of library functions, so you can reuse them, right? You can, with the form of header files, you can declare them using header files and then you can use them. So these are three important points which are going to be advantage with the help of functions. But what is the disadvantage? ऐसे भी हो सकता, due to lot of functions in a smaller program can waste a lot of time. You know, every time you call a function, what happens? You know that? You need to pass the argument and then you need to execute that part of code and you should come back by returning. So here you need to create one activation record separately. So there is lot of stack usage happens in the computer. वहां पर आपको बहुत टाइम कंज्यूम होता है एक स्टैक क्रिएट करना, और उनको बार बार कॉल करेंगे तो बहुत सारे स्टैक्स क्रिएट होता है, तो इससे टाइम वेस्ट होता है ऑपरेटिंग सिस्टम के लिए। तो जब छोटा कोड बनता है, बहुत सारे फंक्शंस की जरूरत नहीं होता। अब अगर कोड बहुत ज्यादा है तो यू कैन ब्रेक इनटू मल्टीपल फंक्शंस टू मेक इट इजी, सिंपल, रीयूजेबिलिटी, तो दैट क्रिएट्स एडवांटेज। बट unnecessarily for simple program you are making lot of functions that will create unnecessary burden on operating system during runtime. ये बात समझना, ये डिसएडवांटेजेस भी होता है अगर कोई भी सही से हैंडल नहीं किया। Got it? राइट। फंक्शंस, कल भी इसके ऊपर सेशन है, टाइप्स ऑफ फंक्शंस, वहां भी हम बहुत सारे डिस्कस करेंगे, राइट। तो अब ये चलते फंक्शन इन सी लैंग्वेज, इनकी सिंटैक्स क्या है? अभी तो दिखाया, एक रिटर्न टाइप होता है और फंक्शन नेम होगा एंड यहां पर आर्गुमेंट्स होगा, आर्गुमेंट्स, डिक्लेरेशन, राइट, एनी नंबर ऑफ आर्गुमेंट्स। by separating with comma, and यहां पर any number of statements। ये होता है सिंटैक्स। अगर यहां रिटर्न टाइप कुछ है तो यहां रिटर्न कीवर्ड यूज करना होगा अंदर, वो भी जरूरी है आपके लिए। कभी कभी ऐसे होता है रिटर्न कीवर्ड एंड यहां पर एक्सप्रेशन हो सकता है जो इसे मैच्ड वैल्यू रिटर्न करने के लिए, सेमीकोलन। और भी स्टेटमेंट्स हो सकता है इसका नीचे, कभी भी रिटर्न करना है आप इस स्टेटमेंट को लिख सकते हैं आप। यस निशु, यू आर राइट। बट ये क्या होता है? इज इट एनफ टू राइट इन सी लैंग्वेज? ये काफी होता है क्या सी लैंग्वेज में? नहीं, ये सिर्फ डेफिनेशन है। ये क्या है? दिस इज अ डेफिनेशन ओनली, मतलब मीनिंग। कभी भी प्रोग्राम में फंक्शन कॉल किया, यहां पर आके एग्जीक्यूट होगा, करेक्ट। एक छोटी एग्जांपल है इसको समझने के लिए, void f, इसके अंदर मुझे कुछ प्रिंट करना है, लेट्स से प्रिंट f गेट, है ना। ये छोटा फंक्शन है, ये क्या समझ रहे हैं आपको? या void लिखा तो अंदर से रिटर्न करना जरूरत नहीं है, ये f इज अ फंक्शन नेम और यहां पर कोई रिटर्न कोई आर्गुमेंट्स नहीं है तो डिक्लेयर करना जरूरत नहीं है। एंड देन इट एग्जीक्यूट्स व्हेनेवर यू कॉल द फंक्शन, इट प्रिंट्स अ गेट, राइट। एक छोटी एग्जांपल है, बट ये डायरेक्टली यूज नहीं होता, आपको कॉल करना होगा। ये डेफिनेशन तो है बट ये ऑटोमेटिकली एग्जीक्यूट नहीं होता, आपको बताना होगा कब कितने बार एग्जीक्यूट करना है, कहाँ कहाँ एग्जीक्यूट करना है। तो इनके लिए कोई भी फंक्शन होता है उसके लिए 3 टाइप्स होता है। एक फंक्शन अगर यूज करना है आपके लिए 3 कॉन्सेप्ट्स होता है। एक जो होता है डिक्लेरेशन ऑफ ए फंक्शन, इसी डिक्लेरेशन को हम कह सकते प्रोटोटाइप, इसी प्रोटोटाइप आप मान सकते हेडर। और ये फंक्शन को समझने के लिए आपको एक डेफिनेशन चाहिए होता, ताकि बार बार इसकी एग्जीक्यूशन यहीं पे होता है, और इनको एग्जीक्यूट करना है तो आपको कॉल करना होगा, इसको बोलते हैं फंक्शन कॉल। करेक्ट? व्हाट इज द डिफरेंस बिटवीन दिस 3? एनीबॉडी हियर? किसी को पता है क्या ये तीनों क्या है प्रोग्राम में? कैसे आप डिफरेंशिएट करोगे डिक्लेरेशन, डेफिनेशन एंड कॉल? ओके, ठीक है। यहां पर 3 things to understand about the function. 1 यहां पर है, यहां भी है, यहां भी है, ये दोनों ऑलमोस्ट सेम है, और ये है। कैन यू टेल मी समथिंग अबाउट दिस? इशू, राइट? ये होता है फंक्शन प्रोटोटाइप। इसकी काम क्या है प्रोग्राम के अंदर? जैसे प्रोग्राम आपको पता है यहां से स्टार्ट होता है कंपाइलेशन, एग्जीक्यूशन तो यहां से बिगिन होता, बट कंपाइलेशन यहां से होता। यहां जब एग्जीक्यूट कर रहा है तो अगर ये स्टेटमेंट नहीं है, देखो सी लैंग्वेज तो आपको पता है टॉप टू डाउन होता है प्रोसेस, तो ऐसे नीचे आया तो एफ कॉल किया, बट एफ ऊपर नहीं दिख रहा है, तो कंपाइलर को नहीं पता एफ का रिटर्न टाइप कौन है, एफ की आर्गुमेंट्स कितना है। तो ये जरूरी होता है, इनका डेफिनेशन जो है बाद में है, ये एक्चुअल डेफिनेशन है, राइट? अगर डेफिनेशन मेन के बाद है, बट आप मेन में फंक्शन को कॉल कर रहे हैं, राइट? ये फंक्शन कॉल बोलते हैं हम इसको, फंक्शन यूज और फंक्शन कॉल, ये भी सेम है। जब कॉल किया है उनके बारे में पहले, जब तक ये पूरा स्कैन हो चुका ऑलरेडी, राइट? बाद में तो स्कैन नहीं हुआ, राइट? तो यहां पर आप कंपाइलर स्कैन कर रहे हैं तो इनको तो पता होना चाहिए एफ ऑलरेडी आया नहीं आया, राइट? अगर नहीं आया तो ये हो सकता है समझ नहीं पाएंगे, राइट? बट आजकल कंपाइलर्स बहुत चालू है, दे हैव द अदर टेक्निक्स टू अंडरस्टैंड। ये जरूर, ये ऑप्शनल होता है, ये लिखना जरूरत नहीं आज की कंपाइलर में, बट द ओल्ड कंपाइलर्स में ये बहुत जरूरी है कि उस स्कैनिंग में एक ही बार स्कैन होता है प्रोग्राम, एंड वहां पर एफ कॉल आया और ये नहीं दिखा तो कंपाइलर को थोड़ा कंफ्यूजन हो जाता। बट ये इनकी जो हेडर है, ये जो हेडर बोलते हैं हम, इस हेडर को इधर कॉपी किया तो अगर पहले ही प्रोटोटाइप आ गया तो यहां पर एफ की सिंटैक्स कंपाइलर को समझ में आएगा, करेक्ट? तो प्रोटोटाइप इज ऑलवेज मस्ट बिफोर यूजिंग इट, बट डेफिनेशन बाद में भी लिख सकते, कोई दिक्कत नहीं। रन टाइम में तो कहीं पर भी जा सकते हैं हम, एफ कॉल किया इधर जंप होकर डायरेक्टली एग्जीक्यूट होगा, क्यों इनकी एड्रेस इधर से स्टार्ट होता है, करेक्ट? तो ये दूसरा वे ऐसे है, ये पूरा डेफिनेशन को सीधा इसको प्रोटोटाइप को हटा के सीधा ऊपर भी लिख सकते हैं। जब ऊपर लिखा है ये फर्स्ट लाइन विल एक्ट लाइक हेडर, तो वह भी सही प्रोग्राम है, राइट। अगर ये फंक्शन प्रोटोटाइप नहीं लिखना है तो अदर वे टू राइट द पूरा डेफिनेशन मेन के ऊपर लिखो, ताकि यहां जब कॉल किया ऑलरेडी ऊपर डेफिनेशन स्कैन किया होगा, तो देन यू विल नॉट हैव एनी प्रॉब्लम टू अंडरस्टैंड द फंक्शन कॉल। ठीक है, समझ में आया? तो व्हाई दिस थ्री आर वेरी इंपॉर्टेंट, बट ये तो ऑप्शनल है। आज ही कंपाइलर अगर ये नहीं लिखा फिर भी समझ में आता है। अगर कोई कंपाइलर एरर प्रोड्यूस किया तो इनको सीधा ऊपर पेस्ट कर दो, हो जाएगा काम। ठीक, और आउटपुट पूछना भूल गया। तो व्हाट इज द आउटपुट? एग्जीक्यूशन कहां से स्टार्ट होता? फ्रॉम द मेन, एंड इट विल स्टार्ट कॉलिंग एफ। जैसे ही एफ कॉल किया तो कहां जाएगा एफ? इधर एग्जीक्यूशन के लिए जाएगा, और ये प्रिंट एफ एग्जीक्यूट होगा। पहले आउटपुट सी है, देन पूरा एग्जीक्यूट करने के बाद फिर इस फंक्शन में जाएगा, और इस फंक्शन इसी को कॉल करेगा। तो दोबारा आपको ये प्रिंट एफ होगा सी, एंड देन इसके बाद फिर इधर जाएगा। इधर कोई स्टेटमेंट नहीं है तो डायरेक्टली टर्मिनेट होगा, करेक्ट। दैट मींस इट रिटर्न्स द कंट्रोल टू द ऑपरेटिंग सिस्टम। तो सी आएगा आउटपुट। सो कोई भी फंक्शन आपको लिखना है, यू कैन डिफाइन द फंक्शन इन मल्टीपल वेज, लाइक ए फंक्शन with or without arguments and without return. What do you mean by that? Just, I'll write a prototype. Void f and then void. ये जो void है नो आर्गुमेंट्स के लिए, ये जो void है रिटर्न के लिए। दैट मीन्स नो रिटर्न एंड नो आर्गुमेंट्स। ये बहुत इजी फंक्शन है। और सेकंड क्या होता है? फंक्शन विथआउट आर्गुमेंट्स। आर्गुमेंट्स हम पास नहीं करेंगे, बट यू कैन एक्सपेक्ट and with return। ये कैसे होगा with return? Example, I want to return integer value. Of course only one value you can return, f, there is no argument. This is for no arguments, but you want a return, right? So that's a return value, return integer. This is a with return basically. Now, आप बता सकते क्या? थर्ड एंड फोर्थ आर वेरी वेरी इंपॉर्टेंट। फंक्शन with arguments. And you can take with return, very famous. And fourth one, function with arguments, no return. राइट, यहां पर हम देख लेते प्रोटोटाइप कैसे दिखता है। विथ रिटर्न, राइट, विथ रिटर्न। सो लेट्स टेक इंटीजर f with arguments, right? Let me take one is integer, other is character, other is float, is your choice. So I have 3 arguments. I can have even all integers also fine, right? There are 3 arguments where first argument is integer, second is character, third is float, and after executing the function it will return integer value. So this is the return type. And if you don't want return, what do? You write a void. Maybe you are passing, let's say, 2 integers, then int comma int. able to understand the prototype of the function. And in this too, the speciality is you are having arguments. So these things again further that we'll discuss tomorrow. There are two types. When you pass the arguments, you can have a call by value technique, or you can use call by reference. There are two types of techniques when you pass the arguments. You have a with arguments. When you say with arguments, how do you call the arguments? Using the value or using the reference? That we will learn tomorrow. Okay, but today we'll practice some of the examples in simple way, and later tomorrow we'll also go into deeper to understand how we are passing the arguments, with values or with addresses. Let's practice some of the questions. I'm avoiding # include yesterday word outage, that you take care of it. Go ahead. What is the output? And let me know what kind of function I'm using as an f here. Easy, right? Anyone? So this is called as a function call, right? What happens when you call it? That's tomorrow. That's what we are going to learn. 5 it will copy to x, 9 it will copy to y. So here x will have the 5 and y will have 9. So you are going to send 5 plus 9 minus 1, which is nothing but 13, right? And 13 will return from here. So it will catch here 13. When you call, and what it returns? It returns 13. So the 13 will be printed as an output. So what type of function it is? The f is, you see, int f. This is called as a prototype, int comma int. And what kind of function it is? F is a function with 2 arguments and with return value as an integer. And 2 arguments are also integer values. You are taking 2 integer arguments and returning 1 integer value. So you have a return type as an integer, and you have 2 arguments. Both are integer arguments. So function with arguments and with return value type. Which type? Function with arguments and with return type. Go ahead. I want you to understand the output. And also a function without argument, without return type. That's you understood, right? F is without arguments and without return type. What is your output? Even though it is a very simple program, तो बहुत बेसिक्स है. Oracle आएगा, call by value, call by reference, then we'll have a storage classes, right? Recursion, a lot of things there to learn. Now you can go for storage classes, you will understand beautifully. Because you are using the functions, you will understand them clearly. This answer? And you know, this F is called, right? What it prints? G, right? This is called, no doubt, right? F is called, it will go and it will come back. This F is also called, will go and come back. So it prints a G and come back. This 10 is assigned to X. Correct? This 10 is assigned to X. When you print X, what it prints? It prints 10. So 𝐂𝐚𝐬𝐬, that's an output. Not just 10, it is 𝐂𝐚𝐬𝐬. Okay. Let's slowly introduce storage classes because we have started the functions. Now you will get more idea about the function. Okay. I'll give an example first, then I'll define all of them one by one. Okay. Go ahead. Can someone help me to answer it? How many of you can tell me what is this? Can I write this as same as auto index register also? Fine. Both will have the same effect. Is it same as auto index? Why we say this is automatic variable? Anybody? I'm introducing one special variable called as automatic variable. So what you are writing here within the block is automatic variable. What is the speciality of automatic variables? Any idea? all the automatic variables, their memory is created on the stack. The storage is allotted on a stack region. Like when you call any function, if you call this main function, automatically there is a stack created for this environment. Correct? So these variables are created, allotted on the stack. Now, by default, if you don't assign the value, what will it be? Garbage value. So all the automatic variables, without assigning a value, please never use it, because they have random values, unknown values, garbage values. Correct? What is the specialty of these automatic variables? Their scope means visibility, access. If I create X here, then I can only access up to here, because this is the visibility of X. If I declare here, then I can access only within that block, right? The scope is within the block only. It is not visible outside the block. Limited to block. Correct? And there is a scope means accessibility, visibility. How long it is visible? How long you can access? Lifetime means existence in the memory. Right? Existence in your RAM, main memory. How long that memory exists in a system? When you enter this block, it created. When you are going out, that will be deleted. The same way, when you enter, this will be created. When you go out, this will be deleted. So when I am here, this X is not available in your system at all. So lifetime is also block, right? Depends on block. Entry and exit. Entry for creation and exit for deletion. Remember that when it is entering into the block, the memory for X is created and 20 will be assigned. When you are going out of the block, only this block I am talking about, not any other block, right? There are two blocks here. This is the one block and this is another block. Okay. So blocks always have the brackets to begin and end. Right. If you don't initialize any value, that initial value, that is initialization, is garbage. Garbage means unknown, random, that you don't know basically. Right? That's why output, when you look at what happens, when you enter, the X is created and 10 assigned, and 10 will print. Here 10 prints. And when you enter, the X is created, that is, oh, sorry, this is 20, no? I'm very sorry. X is 20 and it's 20 printed. And then 20 plus 10, 30. When you are going out, this memory is deleted. This memory is deleted when you are going out. Then when you come here X, when I am accessing in this scope, the only one X is there, that is 10. Here X is there, 10. The 10 is still there, and that will be deleted only when you go out. Here 10 is printed. So 10, 20, 10. Everybody knows, right? So in place of auto, you may use a register too. But difference is in the memory is may be allotted in registers near to the inside the processor, right? So if you keep any value in register, the accessing the time is very less for the register variables, because it's near to the processor. So accessing is very faster than this memory. So memory access takes more time than register access time, right? So if you want to access frequently, like you are repeating loop. In loop, let's say you are accessing 100 times. Then you can keep in a register, you can look at I value in a register rather than looking at a memory. Right? 100 memory accesses, 100 register accesses, definitely there is a lot of difference. and register access is far better than the memory accesses, right? So there is another variable called as the register variable. Just replace auto with register. Keyword is must if you want to say register variable, but the memory can be register or stack. If no register is free, then the system might use a stack rather than register. That is internal, you don't worry about it, but everything else is same. Only the difference is use the register keyword, and by default you can't call register. You should use the register word. Okay, let's take second example. This is one advantage of using register. Register also you can declare within the block only, but advantage is like if you keep that I in the register, you are accessing multiple times. Maybe see, one time, second time, third time, fourth time. So here 100 times I'm entering, so 300 times plus 1 plus 2, so 302 times I'm accessing the I in this execution. So 302 times going to register is far better than going to memory, correct? Going to RAM. Going to RAM is slower compared to register. So in this case, the I is recommended to use in the register. If the registers are not free, definitely this I is allotted on the stack again. So register variable is almost same as auto variable only, but you have to use the keyword. If you don't use the keyword, that is by default auto int. It is similar to block, similar to automatic variable only. Except the memory allotted, that storage can be either memory is either register or stack, depends on the availability of registers. If registers are not available, you can't force, compiler will never force the operating system to give a register. Okay, there is a feature of the C language register type of storage class. Everything else is same. The scope is within the block. If you declare here, well, enter, it creates, and when you go out, it deletes. And accessibility, if you declare here, you can only access in this block, not outside the block. Okay. The automatic register variables are almost same in terms of the visibility, that scope, and lifetime and initial value, everything is same. Okay, only the difference is the memory or storage where it is created. The answer is, what is output? It starts printing from 0, right? 0, 1, 2, 3 up to last value of I is 99. The I you are accessing multiple times, one time, second time, third time, fourth time, and again. So here the I is used many times, or accessed, you can say. I is accessed many times. When it is many times, better put in a register and access it, because it will be, the execution will be faster. Right? Anybody not aware why we use the register in C language? The compiler requests the system, if any register is available, please allot it to this I, so that you may save the execution time. Okay. Can someone tell me the output? I'll wait for some time. What is the specialty of static variable in a C language? If you look at previous variables, automatic variable and register variable, static variable. The difference between these three is this has to be local, never be global variable. Local to the block, any block is fine. But static variables you can declare locally to any block, or it can be global. Is your choice. Local or global. There are two ways to write a static variable. And another difference is the memory is allotted on the stack here. This one is mainly intended for register, but it is not available. It may be stack. But this is a different region called as a data region. A very special region in a computer. The data region, everything is default initialized with zeros. There is no garbage value in the data region. And the specialty of data region is memory is allotted before program starts execution. And at the end of execution only this memory will be deleted. This memory will depend on the scope, like block, right? If it is there within the block, when you are exiting the block, memory will be deleted. There is no such thing here, like block or function. It only depends on program execution, right? This too depends on block execution. The memory creation and deletion both depends on block, right? Memory allocation, or we can call creation or deletion. It depends on block, but here it depends on only program. When the program begins, program begin and end. When it begins, memory created. When ends, program that memory deleted. So whether it is local or global doesn't matter. The memory is created just before start of the execution. And that's the beauty of the static variable. That means this static variable will not be created when you enter. No, this static variable is created when you are starting your program execution. At this point only, all these static variables are created. All static are created in the memory, are allotted in the memory. All static variables memory is created in the data region. This is the point where doesn't matter is it here or here or here, doesn't matter. Is it clear, everyone? That means it knows clearly in the heap region, sorry, I'm very sorry, data region, it knows clearly like there is X global which is initially 0 as you did not assign, and what else, there is another X which is 5 which is belongs to function f, and there is no static variable for the main. It knows clearly all the static variables of this program clearly created in the data region at this point. After this, these lines are compiled and deleted by the C program already. This is not visible at runtime. Remember that. This declaration is not there, but their link is made. When you want to access X, you should access this one. When you want to access X, this should link this one. So this access links, it's a name called as access links. Every function that is called as access link, that access link will help to access the data which is not there in locally. So when you create the stack, there are variables which are there in the stack itself, like local auto variable, but static variables which are there in the data region. So all these links are made during compilation only, because C programming is what? The static scope based programming language, correct? And now you can easily understand, it starts from the main, you call f, it goes here, and x, which x will print? 5 will print. So output, the first one is going to be 5. And you're doing 5 plus 1, 6. And see, when you're going back, that memory will not delete. The memory created only once and deleted at last, right? And I'm going from here to here, like from here I came here, right? Then from here I'm going here. Then this x is still there. When you come back again to this function, the same x will access, not different x. Now when you call f again, it comes here, and when it sees the x, it is 6 right now, so it will print 6. And after this x plus 1, it will become 7. And after execution, again it goes here, and then printf x. This x is what? 0, so it prints 0, correct? And then f, again it calls, and this time the x value is 7, and it will make 7 plus 1, 8. When you come back from here, and no more execution because program is over, main function is over. So 5607 is an output. Anybody printed? 5607. Great. So here x is not available in the main, so it looks at global. This x is going to make a reference here. Everyone able to understand? This is the beauty of static variables. And here the advantage, you see, the previous function call made changes, and the next function call is able to see the changes, because here the static variables are created only once. You can call 100 times, but memory created only once for the static variable, wherever it is. It's global or local, doesn't matter. And when you don't initialize, by default it will have a 0, because data region, any memory that you create, by default it is 0. And specialty of data region, before the program execution only all the static are created. When you are going out of this, when the program terminates, all static, that is all data region, or I can say all static variables, will be deleted. Got it? It's very important, very sensitive. That's why in exam, static variables are very important. Same program, if you do auto, what happens? Anyone? Anyhow, there is no auto global, right? You can't write here. Okay, let me keep that. I'll write it. Auto word you can use or simply int. Just write int. And this x is not auto variable. Remember, this x is what? Global variable. That's it. What is this? Global variable and external. So don't write extern keyword here. Extern wanted when you want to use this variable at some other place. So this is a global variable and useful for all external files. Okay, now what happens? First, when it calls f, x is 5, x is created, and the first output is going to be 5. And 5 plus 1 is 6. And when it is going out of this function, like you have to return from here, no? You have to return from here. When it is going, this memory will be deleted. No more memory, right? When it is going here, from here, the second time, what happens? It automatically deletes from the memory, because the auto variables, their memory exists as long as you are in this scope. Once you go out of this, memory will be deleted. But static variables, the memory still exists. When even though you are here, that static variables are still there in the data region. When you come back here, the previous the variable that you have used, memory that you have used, is still visible here. Okay. Printf x, this x is 0, no doubt. By default, the global variable initializes to 0, and it is also created data region only. Remember, global variables are also there in data region. And f, when you call this, again x will created with 5, and 5 prints, and then 5 becomes 6. When you are going from here to here, then automatically deletes and the program terminates. When the program terminates, the memory of the global data also deletes automatically. Okay. So this variable creation and deletion depends on the program termination, just like static variable, but auto variable only depends on block entry and block exist. And this is visible here, and its lifetime is also up to here only. Correct? This is about automatic variable. Now let's talk about external variables. Right, today's last example. Let me show you 2 programs. Then you will understand very easily. You have written 2 programs. Let's say this is a p1.c, this is a p2.c. And here I have, let's say, int x is equal 10, int y is equal 20, and so on. Here I'll write hash include stdio.h, hash include p2.c, void main. Now I wanted to use that x and y here. So what will I do? I will write, they are global variables but external to all the files. I should write extern int x. I want y also, so I can write extern int. Again, if I want x, I can write, but no use. Now I'll write a printf here. Let's say %d, I'll do x plus y. Now you will understand what is the use of extern keyword. See, all the programs, their global is same. Like, you know, if you write anything above, like it's above only, right? It's a global section. That global section is visible to all the programs, no matter which program that you are linking, right? All the programs which are linked, suppose I linked with 3 files, 2 files, these two files, global section, everybody can see. Like this function can see the global data, but you have to use extern keyword for the variables, right? So now extern int x. So these programs are linked in both of them. This x will be seen. So x is available in p2.c. So this x is linked by the linker. So this x will link with this, and this y link with this. Who will link that? Linker will resolve that external references. Correct? The compiler knows that extern int x means okay, linker will come and resolve it, and just after the compilation, just before execution, your linker will work, and linker will try to link all the external reference, whether it's an external variable or functions also. If you have any function here, then if you call directly here like printf, printf is external, printf is not defined here. So printf is there in stdio.h, and that's also only the header. So this printf is there in library file, it links during linking stage. Okay, so even this printf is also linked during linking stage. Now when you print x plus y, what it prints? X is 10, y is 20. It knows now it is 30. The output comes as 30. This is how you can use the external variables. Right. To do this, you must first include them, because if x, y and in p2.c, then I must write here. Otherwise, this program will not know which file to look at. Okay. And some compilers will look at the default folder, but if that's okay, if it is catching that, that's okay. But we don't know exactly where we keep p2.c. You can keep anywhere in the system. With this, we have completed simple basic definition of a function, and tomorrow we'll have the call by value, call by reference, and recursion. A lot of examples based on it. Okay, so thank you so much for joining today, and see you tomorrow with a new topic, that is the functions, calling mechanisms like call by value and call by reference, and then recursion.